All right, we're going to continue through this test, starting on number 9, which is where we ended on the last video. These problems, just to repeat, were supposed to be pretty straightforward, that you solve them using square roots, and what you have to do is isolate the quantity that's squared. Up here we isolated the x minus 4 quantity. Here we will get the p squareds together. Anytime you're solving or factoring, you have to get everything to one side, set it equal to 0. So I'm going to do add 9p squared, and subtract 4. And I end up with 12p squared equals 3. P squared equals 3 over 12, which is 1/4, right? So the square root, alright, and then p, if I take the square root of both sides, looks like this, right? Where the square root of 1 is 1, and the square root of 4 is 2. Moving on. Simplify the radicals or complex numbers. And I said, when you get any complex answers, write them in standard form, which is this, right? So in order to rationalize this radical, I have to multiply by the conjugate. 1 minus 2 square root of 2. And this is a fraction equal to 1, right? So I'm not changing the value of this, I'm changing what it looks like. So my numerator becomes this. I'm not going to multiply it through yet. My denominator, let's FOIL. First, 1 outer minus 2 square root of 2 inner plus 2 square root of 2. Those zero out, don't they? Minus 2 square root of 2 squared. This, 2 times 2 is 4. Square root of 2 times square root of 2 is 2. This is 8. This is 1 minus 8, or negative 7. So the answer looks like this. These were not supposed to be ultra hard. Alright, on this bottom, we multiply by the conjugate. Again, in the top, I'm going to leave it like this for a moment. In the denominator, let's FOIL it. 3 times 3 is 9. Outer plus 3i, inner minus 3i, they zero out, minus I squared. Well, what's I squared? Negative 1. 9 minus negative 1 is 10. So that's my denominator. Before I multiply anything through, I can actually simplify, because these are products. 6/10 is the same as 3/5, isn't it? So now distribute. I have 9 plus 3i. Whoops. Let me back up. Almost lost my I there. This is 3i times 3 is 9i plus 3 times I. 3i times, this is 3i squared all over 5. Well, I squared is negative 1. 9i plus 3 times negative 1 is 9i minus 3 all over 5. Well, standard form, I want the I second. So if I rewrite this, it's negative 3/5 plus 9/5 I. Alright, that's what it means by standard form. Now, write these in vertex form. Folks, this is not solving. This is completing the square. So we want to change it to get it into this form. Right? So I'm going to move the equals y on this side. First thing I do is I subtract the 3 over. And I get x squared plus 6x equals y minus 3. This space is where I add b over 2 squared to both sides. b is 6. 6 over 2 is 3. 3 squared. I add it to both sides. This thing beautifully factors into x plus b over 2 quantity squared. So b over 2 is 6 over 2 is 3 equals y minus 3 plus 9 is plus 6. Now I have to bring this back over, and I get x plus 3 squared minus 6 equals y. There's the vertex form. Complete the square. We said this is the main reason you learn to complete the square, because in trig next year you'll be working with ellipses and parabolas, and you need to be able to complete the square. So let's try the same thing here. 2x squared minus 28x equals y minus 99. And move that over to 9. Now we can never ever complete the square unless there's a 1 coefficient in front of the x squared. So I have to factor out 2. I'm left with x squared minus 14x. This equals 9. Y minus 99. Well, b is negative 7. Negative 14. Over 2 is negative 7. Squared is positive 49. Well, when I added 49 on this side, I had to multiply it by 2 and add 98 on this side to maintain the equality here. Right, folks? So this thing factors into x plus b over 2 squared, I should say. What's b over 2? Well, it's actually negative 14 over 2 is negative 7. And this equals y minus 1. Add 1 to both sides, and I get 2x minus 7 squared plus 1 equals y. And there is my vertex form. All right, you place a mat around a 30 by 25 inch painting. The mat is the same width all the way around. So this will be x, this will be x, this will be x, and this will be x. What are the outer dimensions of the painting with the mat? Well, the area of the painting with the mat is 1200 square inches. So the entire total length times the entire total width is 1200. Well, let's work it out. This now becomes 25 plus 2x. And this becomes 30 plus 2x. And that whole area is 1200. So I'm actually going to write these the other way. 2x plus 25. 2x plus 30. So let's FOIL. 4x squared outer plus 60x inner plus 50x. Last, 25 times 30 is 750, right? Now I always, if I'm going to solve anything, have to get everything over to one side. So I'm going to subtract the 1200 from both sides, and I get 4x squared plus 110x minus 450 equals 0. Now, unfortunately, this is not factorable. All right? Let's see if we can pull a 4 out from both sides. No, we could pull a 2 out, maybe. Let's see. So this is 2x squared plus 55x minus 225. Well, we can't factor this. We need to use, and I'm going to get rid of that constant, need to use negative b plus or minus the square root of b squared minus 4 times a times c. Well, whoops, that's a negative 225. So underneath, well, this is all over, 2a, which is 4. Notice, I have a negative minus 4 times 2 times negative 225. That'll be an add. So 55 squared is 3025. I'm just working on this now. Underneath that square root 225 times 4 times 2. 1800. All right, let me come up here, running out of room. So it's negative 55 plus or minus the square root of 1800 plus 3025. 4825 all over 4. Okay, so let's take the square root of that 48. the square root of the 4825 is about 69.46. We're going to say negative 55 plus or minus 69.46 all over 4. Well, this is a real world problem, right? The only answer that will work here will have to be the add, because we're not going to have a negative x. So I'm going to take negative 55 plus 69.46, and I'm going to divide that by 4. So x is about 3.62. Well, this is what the question asked. You always have to go back and say, what did the question ask? And it asked, what are the outer dimensions of the painting with the mat? Well, one side is 25 plus 2 times x, and the other side is 30 plus 2 times the x, right? So I'm going to say 3.62 times 2 plus 25. It's going to be 32.24 by plus 30, 37.24. And these are inches, aren't they? Inches, inches. Those are the outer dimensions of the mat and the painting. All right, well, in this case, we had to use the quadratic formula. There was nothing else we could do. All right, I'm going to move on to test B and get a problem in there. This one says, graph and shade the following inequality. Well, folks, we have to graph the boundary quadratic, right? Which means we're graphing it as if it's a quadratic equality. I know it goes down, and I know it has a y-intercept of 1. So again, go back to what we did at the beginning of this test. I need negative b over 2a to get my axis of symmetry. So b is negative 2, negative b is 2, over 2 times negative 1. 2 over negative 2 is negative 1. So I have this inequality. Well, let's not do that. Inequality where the axis of symmetry is negative 1. Let's figure out what the vertex is. Negative of negative 1 squared minus 2 is negative 1 plus 1. Well, negative 1 squared is 1, right? So negative 1 plus 2 plus 1. Negative 1, this is equals 2. So my vertex is negative 1, 2. All right. Here's my negative 1, 2. I know this opens down. My y-intercept is 1. Can mirror that. Now here's where I'm going to graph the boundary line. Whenever something's strictly greater than or less than, it has to be a dotted line. If it's less than or equal to, greater than or equal to, it's solid. So this has to be a dotted line. All right? Now, to shade. It looks like y is less than that graph. I'm thinking maybe it's less than inside, but I need to check a point. I'm going to check 0, 0. So 0, is it less than 0 minus 0 plus 1? Yes, 0 is less than 1. The inside is shaded. Right? We absolutely have to check points on this. This graphing the boundary is exactly the same as what we did at the beginning of this test where we were graphing the quadratic. Now we have to graph that quadratic, either dotted or solid, and then shade. All right? I think I'm going to stop here and pick it up for the rest of it in the next video.